Okay, mathematical reflections 1.
So, question 1. How would you explain to someone how to make a design with A. Reflectional symmetry? And reflectional symmetry is when you reflect an object about a line.
So we would have our polygon, in this case a triangle, and we would choose a line of reflection.
And our line of reflection will be along points B and C.
And then we would reflect the object about line. First we choose the object, then the line. And there is the reflection. A line of reflection can be anywhere, off the object, on the object,
or going through the object.
Yes. For example, here is a polygon that is off the line, a line of reflection away from the polygon, and it can be reflected. Or here's an example of a polygon going through an object, going through the line of reflection.
So then when you reflect this object. Okay.
And the object will look like this.
So that is 1A. And now for 2A, how are points and their images related by each of these geometric transformations? And so for 2A, reflection in line M.
So for example, if this is the line M, and this is the reflection, none of the angles are changed and none of the side lengths are changed. For example, the distance of A to C and its mirror image A prime to C prime are of the same distance.
And another relation is the distance from an image to the line of reflection is the same as from the original to the line of reflection.
But I kind of like that. But it's like how they relate to each other. Like for reflection, it will be and they are.
And none of the angles are changed. For example,
And rotation. Would it be a rotation is the point A is 1 degree.
for example, you always go counterclockwise. So A, B, C, angle A, B.
Each point is it's the same distance from the center of rotation.
That really works.
Yeah, basically it's
Try.
This is B, C, B.
Wow.
BAC is same
As
C prime, A prime, and B prime.
alright. And another thing as for relation, if you connect original point to its prime and it crosses the line of reflection, the angle there is going to be 90 degrees.
And all the lines are parallel. So these lines are all parallel.
Alright, that's for deflection. Now for rotational symmetry. Scroll down, start fresh.
Okay. So we would have our polygon. And then if we want, we have to choose a point of rotation. So a point of rotation can be on the object or off the object.
It can also be an existing point of the object.
Such as J.
And so in this situation, we're going to use J as our point of rotation.
So we would use the rotation tool.
And in most cases, you rotate an object counterclockwise by an angle of your choice. And so
In this case, we will rotate it 90 degrees
counterclockwise.
and of course it would usually be counterclockwise. So the new reflection would look, the new rotation would look like this.
And
If you rotate an object 360 degrees, it would come back to the original object, such as this. We rotate this 360 degrees, it would overlap the original.
And so the distance from a point to
the point of rotation and its prime is the same as the original point, the distance of the original point to the point of rotation.
So it might be easier if you did a square, and then if our point of rotation was point S over here, we could rotate this 90 degrees counterclockwise. And here you can see that these distances are the same. And also, in this situation, the lines connecting the original point, the angle of the original point, the point of rotation, and the original point's image is a 90-degree angle. And so, yeah, now that we have we've done 1B and 2B for rotational symmetry, there's translation symmetry.
First you would have your polygon.
In this case, a right triangle.
Or about right triangle. And then you would choose a vector. So you choose an object, and then you can choose a vector to translate, for example, point V. And I would like to translate this to here. And here you have your new object.
So, the distance between an original point and its image is the same distance as the vector, and this can be shown here. Distance from T to T prime.
And all the distances are the same.
Yes, T prime.
We will measure these distances.
Just to show you. And all these distances are
The same.
and this was accidentally the side, but they're all the same. And if we make a perpendicular line through one, I think.
It would make a right angle.
Which can be hard. Yes, then you can see
It's a 90-degree angle.
which is a bit easier. You can see it's 90 degree. Yeah. And so
To see, how are the points and their images related by each of these geometric transformations? C is translation with distance and direction set by the segment from point x to point x prime. For example, if this is the point I had chosen to translate, so point V, ignore the prime, is then translated to the current location of V prime, ignore the W, or in this case it would be X. These distances are the same as previously shown.
now for 3, in cases of reflection, rotations, and translations, how do these change the size and shape of line segments, angles, and or polygons, if at all?
So as our examples from previously have shown us, none of these have changed the angles or the lengths. We can pick any shapes out of all these, and all the side lengths would be the same as the original.
In other words, the original shape's image is congruent to the original shape.
For example, these distances are the same as well as these, and the angles are the same as. Excuse me, that was.
So from the distance PQ is the same as from.
So PQ
is the same as P
prime and Q prime. These two. And the angles are also the same. We will measure this angle. As well as this one. And you can see that these angles are the same.
And
meaning that all the shapes and their images are congruent.
thank you for watching.